Alright, so these are the notes for Chapter 8, Sections 2 and Section 3. Once again, I apologize for not being able to be there today, but to keep on track with our plan of taking the test on Friday, we're going to do the notes this way for once. So, Section 8.2 is about types of chemical reactions. There's 5 basic types, those types being synthesis, decomposition, single replacement reaction, double replacement, and combustion. Each type is unique, and each type will produce its own unique products. The first ones we're going to look at are synthesis reactions. To synthesize means to create. So when we have a synthesis reaction, we're taking two singular elements. Our generic equation is A plus X. So these are singular elements or polyatomic ions. Remember, a compound is composed of two or more elements chemically bonded together. These are two simple elements. If we have elements with oxygen and sulfur, they will always form oxides and sulfides. So these are a couple special unique cases where whenever we have a synthesis reaction involving oxygen or sulfur, the products will always be an oxide or a sulfide. Same things like with metal and hydrogen. Whenever we have a metal and a hydrogen atom or hydrogen atoms reacting, we'll always form, or halogen, we'll always have metal halides form. Our next type is decomposition reaction. In a decomposition, we have a binary compound that we start with, and we split it apart into individual elements or individual polyatomic ions. One way binary compounds can actually break apart is through the process of electrolysis, which is using electric current flowing through a material in order to break it apart. We can actually use electrolysis to take water. If we run electric current through it, split it apart into hydrogen gas and oxygen gas. Hopefully I'll get a chance to demonstrate that later this week. If we start with a metal carbonate, so if a metal carbonate is our reactant, we will actually break it apart to form metal oxides and carbon dioxide gas. Carbon dioxide gas will always be a product when we have metal carbonates. Similarly, metal hydroxides will always break apart to form metal oxides and water. So water will always be a product of a metal oxide decomposing. Again, with metal chlorates. We've actually seen an example of metal chlorates with the percent composition lab, where you did either potassium chlorate or sodium chlorate. And then finally, acids will always break apart to form oxides and water. Single replacement is different than both synthesis and decomposition in that we start with a singular element and a binary compound. We have two different forms. We can either have a singular element that is acting as a cation that's going to replace the first element, or we can have one that's acting as an anion and actually going to replace the second element in the compound. Remember, in binary compounds, they're listed as cation first, anion second. Some examples of this is a metal replacing a metal in a compound. Hydrogen and water being replaced by a metal. Hydrogen and acid being replaced by a metal. And finally, hydrogen being replaced by other halogens. Double replacement is our next type. Double replacement, just the name implies, we're going to actually be replacing two things. So this is different from synthesis reaction, and instead of starting with a singular element and a binary compound, we're starting with two binary compounds, and we're producing two new binary compounds. So basically what happens is they switch partners. So A is with X to start with, A ends up with Y. B is with Y, B ends up with X. So they switched which elements they were with. Usually in a double replacement reaction, one of the products always either forms a precipitate or a gas. We've looked at this with our lab we started on Friday. And in the case if we're reacting an acid and a base, an acid-base neutralization reaction is actually a double replacement, and we're switching the acid with the base to form water and some other salt. Combustion is our final type. Combustion reactions are very simple. Looking them at first glance, they can almost be confused with a synthesis reaction, but there's several unique characteristics that only apply to combustion reaction. One being that a combustion reaction must include a hydrocarbon. Remember, a hydrocarbon is just hydrogen and water chemically bonded together. A combustion will always have oxygen as one of the reactants. And the only two products that form from a combustion reaction are carbon dioxide and water. So every combustion reaction will look the exact same in that it has oxygen as a reactant, carbon dioxide as a product, and hydrogen as a product. The only thing that'll change in different combustion reactions is what the hydrocarbon is. For our notes on 7.3, in the book, they're actually only 1 page long. It just goes through the process of how to use activity series. Activity series is just a list of elements according to how chemically reactive they are. So we list them at the top for elements that are extremely reactive to ones at the bottom that are very unreactive. Elements can only be replaced by other elements that are higher up on the table than them. Yes, it can only replace elements higher up on the table. So here's that list of activity series. So for metals, lithium will pretty much replace any other metal when it's in a compound or a single replacement reaction or double replacement reaction. Gold, being at the bottom, will not replace anything. Under very few circumstances will gold ever actually take place in a single replacement reaction. Gold can be replaced by all these other elements listed above it, but it cannot replace anything itself. A couple things to also keep in mind is looking at these individual categories for each activity series. So the elements at the top react with water, acid, oxygen, and forming oxides, whereas these elements in the second group will react with acids and steam. They will not react with cold water. So that's one condition that must be met in order for one of these elements to replace an element below it. Such as down here, these elements do not react with water at all. So these cannot replace anything in water, only reacts with acids. So today we covered the 5 basic types of chemical reactions, the generic equations for them, and any special cases involving them, as well as activity series and how to use an activity series to predict whether a reaction will happen or not. Have a good day, and I will see you all tomorrow.